आज का वीडियो लेक्चर है ए पार्टिकल इन थ्री डायमेंशनल इन्फिनिटली डीप पोटेंशियल वेल। ए पार्टिकल इन थ्री डायमेंशनल infinitely deep potential well। जैसा कि लास्ट वीडियो में हमने देखा था वन डायमेंशनल पोटेंशियल वेल, तो आज है थ्री डायमेंशनल पोटेंशियल वेल। लेट अस नाउ suppose that the particle is restricted to move in a box with sides A, B and C. Let the wall of the box be impenetrable and so probability of finding the particle at the walls of the box is 0. That is psi 0 yz is equal to psi x 0 z is equal to psi x y 0 is equal to 0, psi a yz is equal to psi x b z is equal to psi x y c is equal to 0. Equation number A, equation number B. Equation 1. Now the equation of motion for free particle constrained to move in the box is del 2 psi over del x square plus del 2 psi over del y square plus del 2 psi over del z square plus 2m over h cut square times e psi is equal to 0. Equation number 2. Let the solve this equation by method of separation of variable so that we may write psi function of x y z is equal to x function of x, y function of y, z function of z. Putting this in equation 2 and dividing by x y z, we get 1 by x del 2x over del x square plus 1 by y del 2y over del y square plus 1 by z del 2z over del z square plus 2m over h cut square e is equal to 0. Equation number इसको इक्वेशन नंबर 3 देंगे, ये इक्वेशन नंबर 4 हो जाएगी। The above equation may be written as 1 by x del 2x over del x square is equal to minus 1 upon y del 2y over del y square minus 1 upon z del 2z over del z square minus 2m over h cut square e। तो स्क्रीनशॉट ले लीजिए, फिर पढ़ते हैं आगे। In above equation, left hand side is function of x alone, while right hand side is function of y and z variables and is independent of x. Then there is necessary that the value of quantity to which each side is equal must be independent of x, y, z. That is, a side must be equal to a constant minus kx square, say, so that 1 by x del 2x over del x square is equal to minus kx square, and minus 1 by y del 2y over del y square minus 1 by z del 2z over del z square minus 2m over h cut square e is equal to minus kx square. Equation 5 and equation number 6. Equation 6 can be written as 1 by y del 2y over del y square is equal to kx square minus 1 by z del 2z over del z square minus 2m over h cut square e. In above equation, LHS is function of y only, while RHS is function of z alone. So we can use any constant minus ky square which is equal to both sides. So we may write 1 by y del 2y over del y square is equal to minus ky square, equation number 7, and kx square minus 1 by z del 2z over del z square minus 2m over h cut square is equal to minus ky square, equation number 8. Equation 8 may be right in this form: kx square plus ky square minus 2me our h cut square is equal to 1 by z del to z our del z square. Equation number 9. In equation 9, both sides are independent of each other, so we write 1 by z del to z our del z square is equal to minus kz square. Equation number 10. और kx square plus ky square plus kz square is equal to 2me by h cut square. इक्वेशन नंबर 11. स्क्रीनशॉट ले लीजिए, फिर बढ़ते हैं आगे. From equation 11, E is equal to h cut square by 2m bracket kx square plus ky square plus kz square. Question number 12. The general solutions for equations 5, 7 and 10 are given as x is equal to a1 sin kx x plus b1 sin cos kx x. Y z is equal to a2 sin ky y plus b2 cos ky y. Z is equal to a3 sin kz z plus b3 cos kz z. Equation number 13. Applying boundary condition, A and B, we get b1 is equal to b2 is equal to b3 is equal to 0. Then we have x is equal to a1 sin kxx, y is equal to a2 sin kyy, z is equal to a3 sin kz z. Equation number 14. And now from equation B, sin kx a is equal to 0, sin ky b is equal to 0, sin kz c is equal to 0. Equation number 15. Then kx a is equal to nx pi, ky b is equal to ny pi, and kz c is equal to nz pi, where nx, ny and nz are integers which none is equal to 0. स्क्रीनशॉट ले लीजिए, फिर बढ़ते हैं. From above expression, kx is equal to nx pi by a, ky is equal to ny pi by b, kz is equal to nz pi by c. Now we get x is equal to a1 sin kx nx x by a, y is equal to a2 sin ky ny y by b, z is equal to a3 sin kz nz z upon c. Now the wave function psi x y z is equal to a1 a2 a3 sin kx nx x upon a sin ky ny y upon b sin kz nz z upon c. Now a1 a2 a3 will be equal to a constant a sin kx nx x upon a sin ky ny y upon b sin kz nz z upon c. From normalized condition psi x y z is equal to 2 root 2 upon root a b c sin kx nx x upon a sin ky ny y upon b sin kz nz z upon c. Substituting values of kx ky and kz, the energy E is expressed as E nx ny nz is equal to pi square h cut square upon 2m bracket nx square by a square plus ny square by b square plus nz square by c square ब्रैकेट क्लोज. तो स्क्रीनशॉट ले लीजिए, फिर बढ़ते हैं आगे. Now the least possible energy, that is ground state energy, by putting nx is equal to ny is equal to nz is equal to 1, that is E 111 is equal to pi square h cut square upon 2m 1 by a square plus 1 by b square plus 1 by c square. Clearly the value E is equal to 0 is impossible. For spherically symmetric well, A is equal to B is equal to C. The energy is E and X and Y and Z is equal to pi square h cut square upon 2 m a square bracket nx square plus ny square plus nz square. The ground state energy for spherically symmetric well is the ground state energy for spherically symmetric well is E111 is equal to 3 pi square h cut square over 2m a square. It is clear from above equation that there may be several modes possessing the same energy. E211 E112 is equal to E121. The state giving the same energy of a combination of quantum number nx, ny and nz are called degenerate state. So we can say in deep potential well the energy is not continuous but discrete. तो इस वीडियो को यहीं समाप्त करते हैं, मिलेंगे नेक्स्ट वीडियो में. थैंक यू फॉर वॉचिंग द वीडियो.